The capacity of a buffer simply refers to how much acid or base can we add to a buffer solution before its pH will significantly change. And so in this example, we have the same conjugate pair being used, acetate ion and acetic acid, and at equal concentrations in each buffer solution, but the concentrations of the second buffer are about 100 times more than the buffering concentrations in the first buffer. So I've created this little chart here to kind of represent this situation. So in buffer 1, I have equal amounts of acid and conjugate base, but the concentrations are quite a bit lower than the second buffer, which also has equal concentrations of the same conjugate pair, but at a higher amount. And so that means that with the first buffer, I can add relatively small amount of acid or base before the buffering components are consumed. So for example, I can only add this much acid before my conjugate base is completely consumed. Whereas in the second buffer, I can add a lot more acid because I have a lot more conjugate base to consume the addition of that acid. Okay, and so once one of those components in the buffering solution is completely consumed through neutralization, you no longer have a buffer and the pH is going to start to change significantly. So in this example, both buffer solutions would have the same pH since they involve equal concentrations of the same conjugate pair. However, the first solution can only withstand the addition of a small amount or smaller amount of acid or base before its pH will significantly change. The second solution will be able to withstand the addition of a larger amount of acid or base before its pH will change significantly. This is due to the difference in buffer capacity. Okay, and so the first buffer we would say has a low capacity and the second buffer has a high capacity. So the following the addition of hydronium hydroxide ions, the ratio of conjugate base to acid would be much more affected for a low capacity buffer than for a high capacity buffer. Okay, and so if we just do a quick pretend calculation here, say for a low capacity buffer, my ratio is 10 to 10. And so if I add an acid or a base, I'm going to affect this ratio. And let's say I affect this ratio by +1 and -1. So the ratio goes from 10 out of 10 to 11 out of 9. Okay, so that's a ratio of 1 to 1.2 repeating. Now let's say I have the same thing, but now this ratio is say 100 to 100 because I have a high capacity buffer, higher initial concentrations. And so when I change this +1 and -1, I'm now going to get 101 out of 99. And so that ratio is a lot smaller. That works out to being only 1.02, and so the change is from a ratio of 1 to 1.02. So we can see that that ratio is a lot less affected when I have a higher capacity.